Hello, good evening, everybody. This is Jima once again, and I'm still under the topic calculus. However, today I'm going to start a new subtopic under calculus, and that is integration. So, integration is another aspect of calculus. Before I move forward, I just want to give this note that um, whoever wants to watch this video is advised to check out my previous videos on differentiation, because you need some introductory knowledge on differentiation before you can really understand integration. So, integration is the inverse of differentiation. Okay, thus sometimes integration used to be called anti-differentiation. Okay, integration is sometimes called anti-differentiation. Okay, just because it is the reverse of differentiation. There are two classes of integration procedures. The first one is indefinite, and the second one is definite. So for this first video under integration, I'm going to be dealing with the indefinite integral. Now, indefinite integral. Generally, I'm going to take it from differentiation. If dy dx is equals to a and ax raised to power n, this is differentiation. If you want to find y, then you say y is equals to ax n raised to power 1 and ax raised to power n plus 1 over n plus 1. Please take note of this. They are always, whatever is the power will be the denominator. Whatever is the power will be the denominator plus a constant. So just take note of that. So this is differentiation and this is integration. So sometimes the symbol of integration is used, and generally integration is represented using this symbol. Okay, that is the symbol for integration. Thus, if I'm going to use this symbol, right, this symbol, then I can say the integral of ax raised to power n dx is equals to ax raised to power n plus 1 over n plus 1 plus c, right? So I just want to again give another note that the above formula is true only if n is not equals to minus 1 and the function is not a trigonometric functions. It's not a trigonometric function. If you have these two conditions, a condition where n is not equals to 1 and the function is a trigonometric function, you are not going to apply this formula. I'm going to bring another one when I start treating integration of trig function. So in this case, for this lesson, we are going to be using this formula and this formula. Okay, so let's see. First example, example 1. Given that dy dx is equals to x, what is y? What is y? So score booster solution goes thus. I'm just going to take it as if we are teaching JS1 or SS1 students, just for you to understand. So I will start by writing the formula. Okay, the formula is if dy dx is equals to ax raised to power n, y is equals to ax raised to power n plus 1 over n plus 1 then plus c. So if you look at what we have here, we have dy dx is equals to x. So if you want to write this one, you're going to put this coefficient of x, which is 1, then x raised to power 1. So if you compare the question here with the formula, you discover that your a is equals to 1 and your n is equals to 1. So if you come here now, this is the integration. So you say y is equals to your a is 1, x still remain what it is, then your n is also 1, so 1 plus 1 over 1 plus 1 plus c. So if you simplify everything, you have 1x 1 plus 1, which is 2 over 2. Okay, and you have 1 over 2 x squared plus c. That is the final answer, as simple as that. Let's look at another example. Example 2. Given that dy ds is equals to 5, find y. Find y. This is a constant this time. So score booster solution. Still, this is the same thing. Let me try to explain. Okay. Now what do we have? We have the question is dy ds is equals to 5. So once you write the formula, this is the general formula. Dy ds generally is ax raised to power n, and y is equals to ax n plus 1 over n plus 1 plus c, right? So dy ds is equals to 5, which you are given. Now you try to create x together with 5. So you then remember that in indices we said anything raised to power 0 is 1. What I'm saying is this. What you have is dy dx is 5. This 5 is the same thing as 5 times 1. Okay, it's the same thing as 5 times 1. What I mean here is times and not multiplication. So I can say 5 times 1. Okay, and we say anything raised to power 0 is what? Is 1. So instead of 1, I can write x raised to power 0. I am putting x raised to power 0 because what I need is x. If I have needed y, I will put here y raised to power 0. Okay, now 5 times x raised to power 0 is 5x raised to power 0. That is why I have written this one. Okay, now the solution still from the general formula is y is equals to ax raised to power n plus 1 over n plus 1 plus c. So now we have 5, which is our a. Okay, remember this is a and this is n. Okay, so our a is 5, then x raised to power 0 plus 1 over 0 plus 1, right? So you have 5, 0 plus 1 is 1, so you don't need to write anything here. This is 1, and 0 plus 1 is also 1. So 5x over 1 is 5x, then plus c. I hope you get my explanation. So let me pick another example 3. So in this example, I'm trying to bring together varieties of terms. In this case, we have 3 terms. So the question is, evaluate integral of x squared plus 2x minus 5 dx. Same thing. What this question is asking for is for you to integrate. I have added some notes here. You see, in this question, there are 3 terms. That is x squared, 2x, and 5. These are the 3 terms. Each term will be integrated separately and then combined together at the end. Okay, so what we are indirectly doing here is to apply the sum or difference rules as we did in differentiation. So this is the solution. First of all, I'm going to write my formula. I said if you have dy dx is equals to a x raised to power n, okay, your solution will be y is equals to a x raised to power n plus 1 over n plus 1. So I will take the first term. Don't forget, what we have is x squared plus 2x minus 5. This is what you are given in the question. So the first term will be this one. And if you are going to write this one, to find your a, you put 1 here. Okay, and that is why I have the first one, dy dx. First one is 1x squared. So my a is 1, my n is 2. So if I come here now, it's going to be 1 s 2 plus 1 over 2 plus 1, and that will be 1 over 2 plus 1, which is 3, then 2 plus 1 here, s cubed plus c. That is the first one. Now the second term is 2x. So I will come here, that's dy dx, second term is equals to 2x raised to power 1. Okay, because there is nothing here, it means what is here is 1. Okay, since there is nothing here, you just put 1. So you have 2x raised to power 1. And the answer is going to be 2x 1 plus 1 over 1 plus 1. So that will be 2 over 2s squared plus c. So 2 cancels 2 here. So you're going to have 1. Okay. And 1, you may not write it, plus c2. So the second term is dy dx. Second term is equals to 5x raised to power 0. Because anything raised to power 0 is 1. Okay, so my a is 5, my n is 0. So if I come here, I'm going to have 5x 0 plus 1 over 0 plus 1. And that will be 5x plus c3. So what's next? What to do now is the overall value of y is going to be the sum of all the y's. This one, and this one. So that will be y1 plus y2 plus y3. So we have 1 over 3 s cubed, which is this one, plus s squared, which is this one, plus 5s, which is this one. Now all the c can be added together to form just one constant c. Okay, and this is your final answer. Having done that, so the next thing is for me to give you what to try your hands hand, and this is exercise. So exercise are listed as follows. So evaluate Okay, the first one is this, and this is your answer, and the second one, this is your answer, and the third one. So I want you to try your hands on this and see what's happened. This will tell you if you really understand the topic or not. So in my next lecture, I'm gonna go to the definite integral, and from there we can solve some past question from them. Thank you. Bye bye.